Guys, welcome back to a new video here with Flow Boatworks. In the last one we finished up the ribs, we did the wedding, we did some of the aft cockpit layout and stuff. And today it's going to be very exciting because today we were going to start with the actual Depron on the outside of the hull. Depron looks like this. It's a very, very flimsy material. Sound artists also use it to make thunder, for that matter, but this will be used to cover up all the outer hull of the boat, essentially. I've never used Depron before. I definitely will run into some problems, especially in the forward area with the cowling about flare, because I have a variety of different directions that the Depron has to go through. So, well, on the side I can use the Depron in its full width and its full height, because I don't have many curves to go around it. But on the bow of the boat, I think I will have to do the Depron separately with small stripes, much like planking as well. Just that this is much faster to do because I will glue it with hot glue, momentarily glue it with hot glue onto the wood because it's fast and cheap. And once it's cured and I'm happy with how the Depron has kind of glued up on the hull, on the ribs, I will then use Gorilla Glue from the inside to make it permanent. And after that, after all of that is done, I will definitely have to do some epoxy and fiberglass work. Probably sanding not so much, and filler because it's very flimsy material and I cannot do a lot of sanding. So all the body work has to be done afterwards. So get a layer of epoxy and fiberglass over the Depron, and then afterwards it's sturdy enough to actually go in and do the filler work and the sanding work. So Depron, probably glassing, filler, sanding. At the end of the process I will attempt to do a gel coat to the outer hull to make it look perfect.
For my boat, I evaluated several construction methods. Large-scale 3D printing would require an industrial format printer and roughly 10 to 15 kilograms of filament. Practical for a 1 meter boat, but inefficient at this scale. I also considered producing a foam-positive plug and laminating fiberglass and epoxy over it, but without prior experience in composite layup, I chose to return to planking. This time using a different material instead of wood to make the progress faster and more cost-effective. I started with the aft section along the sides of the hull, as it is the most straightforward area, clean straight lines with no compound curves. In this section, the Depron adheres easily to the wood structure even when secured only with hot glue. Once each sheet was aligned and fixed to the ribs and transverse beams, I trimmed the substantial excess material with a Stanley knife.
Okay, so the first layer of Depron is completed, and well, what to say, it is immensely fast. It's a fast process, definitely. I mean, of course, you don't have the rigidity of a normal planking, so that's something to look out for later when applying the fiberglass. So I have to apply more layers, definitely. But I do think that it is quite a good option to do. It's fun to do because it really takes on the shape of a real ship, and well, let's see.
One of the defining aesthetic features of a Viking design is the flowing lines through the section, which demands precise shaping in addition to cutting the correct angle at the aft of the saloon, the forward edge of the cockpit.
So I know it's not like as sturdy as wood, but it feels quite sturdy once it is on the rib. So let me just give you some ASMR examples of that. You see that? Well, I think this might just work out. So I apply the glue, the hot glue. Everything has to go fast because it dries up so quickly. So yeah, really speed is of the essence here.
I initially struggled to keep the Depron in the intended curvature while gluing.
This is amazing, guys. I just love this. This was the easy part, all straight. Kind of Depron, but now it gets tricky as we come up to this curvature. So this is where we really have to kind of And I know, try something.
After trimming away the excess and relieving the internal stresses caused by the overbending, the material settled into shape. The resulting line is clean and well defined, and it already gives a strong impression of the final form.
This right here is still quite flimsy, so I will have to do some more structural work. Definitely not one of my proudest contraptions that I've built. It looks, well, not too good, but the good thing is that this will never be seen again, and the reason why I did not a single one up there, so this way a single one, maybe a single piece of wood, is that I still need to get to the bow thruster if kind of this is broken, so I need to have some space. Too much of material was...
In this stage of the build, I shifted focus to the cockpit area, an essential section that defines both functionality and the visual character of the aft deck. I moved on to shaping a small sheet of Depron. I introduced a series of controlled relief cuts, carefully spaced and not penetrating fully through the material.
Pretty cool. It's going to be the fish box, and thinking about it, I probably should have used more of this thing because it's so easy to use, but this is pretty cool. I made some cutouts in the Depron, and if you see this, let's get the exposure right, but you see I made some cutouts in the Depron. And what this does, it gives me the opportunity to actually make nice curves here. And the fish box obviously has curves, nice beautiful Viking curves. And this is really, really nicely executed in this way. And later on, again, glass fiber and epoxy.
As a result, the panel could be smoothly bent and conformed to the compound curves of the boat, especially around the tied radii at the aft corners. This step is key to achieving a clean, continuous surface without stress, fractures or unwanted deformation. One thing I've learned during these builds is how important it is to manage your workflow. Boat building is by nature highly repetitive. What you do on the starboard side, you repeat almost identically on the port side. While that's necessary for symmetry, I personally try to avoid getting stuck in that loop for too long. Instead, I deliberately switch between different areas of the build, moving from structural work to detailing or from hull shaping to cockpit fabrication. Helps maintain focus and keep the process engaging. That said, the larger structural sections still demand consistent and methodical progress. With that in mind, I moved on to shaping the Carolina flare. To achieve this, I cut the Depron into narrow strips, similar in concept to traditional wooden planking. This allowed me to gradually build up the complex curvature of the bow flare. Once positioned, I removed the excess material using a Stanley knife, which significantly improved how the structure set against the hull. At this stage, the surface still looks rough, and honestly, with more practice, it could probably be cleaner. But refinement comes later, and this phase is all about establishing form. For centuries, master shipbuilders shaped long, narrow wooden planks and fastened them to ribs to form a watertight hull, a skill that took years to truly master. With the rise of mass-produced pleasure craft after the 1950s, fiberglass molding transformed the industry, allowing builders like Viking, Yacht to use massive CNC machine plugs to create precision molds for hulls and superstructures. Switching things up again, I returned to the cockpit, using a saw I cut open for the portside access door. In a full-scale vessel, this door is used to bring large catches like tuna or marlin on board. For the model, the door will be 3D printed and installed later. From there, I moved into fiberglassing, one of my favorite parts of the process. Unlike sanding, which is more labor-intensive, fiberglassing feels controlled and almost meditative. With music playing in the background, it becomes a very focused and rewarding step. For most of the hull, I used 160 gram per square meter fiberglass cloth. In this specific area, however, I applied a different cloth, mainly because I had it available and wanted to make use of it. This area will undergo significant bodywork later anyway. Normally, major bodywork is completed before fiberglassing. However, due to the flexibility of the Depron on this stage, sanding or applying pressure would risk damaging the structure. Because of that, I'm postponing a large portion of the bodywork until the fiberglass layer has reinforced the hull. Only the most significant gaps and structural corrections are addressed beforehand. After completing a substantial portion of the fiberglassing, I installed the bow thruster. This involves cutting the opening and securing the unit in place with filler. I also began preparing the mount for the air-cooled brushless motor adapted from an RC aircraft. The bow thruster will be powered from a brushless motor with the 3D printed motor mount yet to be designed. Once that is complete, I'll finally be able to close up the bow section, which at this stage remains one of the last unplanked areas yet of this boat. To finish off the fiberglass work, I trimmed the excess material using a small angle grinder. This step requires careful handling. Fiberglass dust is hazardous, so I always work with proper ventilation, often outdoors, and use appropriate safety protection.
Port side planking is already done. Now I'm going to do the starboard planking, left side planking. I mix those up quite often, but I'm using hot glue to get the Depron to hold on the wood. And I had heard a lot of criticism for using hot glue, but actually the fact is that how good the glue will hold depends on the glue, but also the surface on which the glue is held on. And this is very flimsy material, and actually I've done something mistakes while doing the planking, and I ripped it off, and what happened is that some parts of the Depron got stuck on the wood. So this is actually stronger than this, and it's kind of a free-flowing rib structure once it's all done, because the hot glue is not that sturdy. But of course all the glass fiber here on top will make it that sturdy, and will make sure that it's sturdy and it doesn't move around. Also, I've done the bow thruster already, almost complete. Yeah, so it's just got a Depron today. We'll finish this upper part with glass fiber. And then, yeah, it's slow progress, but we'll get there. And there's still so many rough edges, even more rough edges than there have been on my latest build mode, the RC Trawler. But they will all get figured out, and then it will be a beautiful boat to drive around and to work on later with the bodywork. So quite exciting times.
After working across multiple areas of the boat, the aft section, cockpit, door cutouts and bow thruster, I returned to the hull to begin shaping the starboard side of the Carolina flare. Having already completed the port side, there was a noticeable improvement in both speed and accuracy. The process became much more refined once you've established the method, and that progression really shows here. Interestingly, the final curvature of the bow deck isn't defined by the deck itself, but by the hull plating along the sides. The initial Depron cuts on the bow deck produce a true round profile, so I had to glue in additional strips to build up the correct geometry. These acted as filler material, which I later ground down to create a smooth, continuous surface ideal for fiberglassing. To reinforce this critical area, I took the hull outside into natural light and carried out grinding and initial glass work on the bow. This step is essential to lock in the surface early. Without fiberglass, the Depron remains too flexible, and over time there's a real risk it could deform and lose its intended form.
Really struggling with the glass fiber work. It's not that easy. When the Carolina flare really goes like this, with like a 230-degree angle that has to be glass fibered over, otherwise it would not hold. So that's a big issue. Also, of course, the Depron, while it's very quick to work with without needing any tools except Stanley knife and a hot glue, it's very unsturdy, very flimsy. So what that means, I have to do more glass fiber work. The trawler that I built with wood, regular wood, and that gives it way much rigidity from the start. Only had to do one glass fiber of it, but with this boat, especially in the parts where I might run into things like, or on the edges, the bow, the stern and that stuff, I have to do multiple layers of glass fiber.
Back in the workshop the next day, I turned the hull over for the first time and began trimming excess fiberglass. As always, this is done with full safety precautions. Next, I applied the largest hull plate so far to the underwater section, spanning from rib 6 to rib 9. Because this section of the hull is relatively straight, I was able to use a single large plate, which significantly speeds up the process. To support the forward hull plating, I also installed a small wooden backing plate. This provides additional surface area for bonding and ensures a stronger, more reliable connection as the plating continues forward. At this stage, progress is rapid. The aft section of the planning hull is comparatively simple, far less complex than, for example, a displacement hull like a trawler. Large sections come together quickly. I then cut in the propeller tunnels. These are recessed sections of the hull that allow the propellers and shafts, prop shafts and tubes to sit higher within the hull. This reduces draft and improves protection while maintaining efficient thrust lines. Once both sides were completed, I finished the area with additional grinding and filler. Although it's repetitive work, it's incredibly satisfying to see both sides come together so quickly. After that, I carried out some initial filling of the gaps and imperfections using a filler, but only lightly. At this stage, the structure is still relatively delicate, so heavy finishing work will come later. With that done, it was time to move into epoxy work. I'm using a low temperature curing epoxy system suitable for conditions down to 5 degrees Celsius, since this build is taking place through winter and early spring. The mixing ratio for this particular system is 100:40 in grams, though this always depends on the specific product being used. Always measure ratios precisely. Accuracy is critical for proper curing. Mix in plastic containers. I use simple yogurt cups. Avoid glass as heat buildup can cause it to crack. Mix thoroughly for at least 1 minute to ensure a consistent blend. Apply an initial coat of epoxy to the surface before laying the fiberglass cloth. Plus position the cloth, then fully wet it out with another layer of epoxy.
Quick update on the boat. I've used pretty much almost all of my Depron. I got 3 sheets left of the 10 sheets that I bought. But that's enough to finish up the hull plating work on the forward section of the boat. Before we do that, the bow thruster still needs to be glued. Well, the tubes of the thruster still need to be glued onto the actual thruster. Also, I will have to make a mount for the brushless motor, which powers the thruster, and this will be 3D printed and probably reinforced by fiberglass. Other than that, I did the hull plating for the better part of the bottom hull of the boat. This is rib number 6 all the way to rib number 9 back there. I did use some of my filler to actually make it smooth and seamless, and I will now apply fiberglass in the next step as well. Very exciting, because then only the forward part of the bottom hull will be missing. So of course regular wood with fiberglass will be much sturdier, but this is just fine. It gets the job done. And in the forward area, in the forward section, and in the aft section as well, where I might crash the boat, I will put on another layer probably, because just to get more rigidity. And you know what happened with my last boat with my trawler, one of the connectors of the brushless broke loose, and then I was headed with only like 3 kilometers an hour, but still I was headed into the rocks, and this broke my boat, well, the forward area of my boat. So things like this happen, and this is way faster. It's going 20-25 kilometers an hour, so about 12 to 13 knots, so way more energy that could destroy the boat. So I have to make the critical parts sturdy. definitely. Other than that, pretty excited with the build process. Also, the Depron is just so fast. Like these two areas, the back areas of the boat, I got them on to the ribs yesterday, and now I'm finishing off with some filler, and then it's ready for glass fiber. So, and like it only took me 3 or 4 hours, so it's really fast. Definitely fast. That's pretty cool. Just came back from 1 week of work and came back to this. The epoxy completely dried up. The biggest part done yet, the biggest glass fibering done yet. And I'm so amazed. Also, I'm amazed at what multiple layers of glass fiber will do to the stability, to the ruggedness of the material. So I done 1 layer all the way up here, but I done multiple layers at the prop shaft. So where the prop shaft will enter the boat, where the rudder housing will sit, just to make it more sturdy. I'm really glad with how it all turned out. I mean, there's only one spot specifically that I need to redo, but all the other spots are not spotless, but they are very sturdy and it's very nice to look at them. Very excited. So next step will be finishing up the back of the boat with fiberglass, but more importantly, finishing up the bow thruster, the work on the bow thruster. So that's going to be happening today. Probably not today because I still need to design the actual mount for the bow thruster motor for the brushless. But when that is done, I can finish up the good work done here, and I'm very excited to do that. So things are looking good. Things are looking good with my boat.
After the fiberglass on the bottom hull had fully cured, I went in with a small angle grinder and trimmed everything back clean. At this stage, the bottom hull and stern still aren't tied together with fiberglass. That's intentional. From experience, wrapping large sheets around tight corners just doesn't work well, so I leave those areas for later and reinforce them with smaller strips instead. I moved outside to grind down excess material and clean up any resin drips along the hull sides. Once that was sorted, I started applying filler, mainly to strengthen weaker spots and smooth transitions, especially along the bottom hull and the cabin sides. Next step was fitting the prop shafts. This part takes patience. They need to be perfectly aligned with the keel and parallel to it, which sounds simple but gets tricky fast because of the hull's curvature. I used the keel as a reference line, measured carefully and dry fitted everything first, no glue. Once I was happy with the alignment, I locked them in place with epoxy and fiberglass. Same procedure on the other side. Later on I'll add a support bracket between the hull opening and the prop to reduce vibration. While working topside, I took some inspiration from sport fishing boats. A lot of them have helm stations with a slight outward bulge. Not exactly true to the Viking 50C, but it helps shed water more efficiently. So build up that area slightly, shaping the future helm platform with extra fiberglass to keep it solid. From there, I moved into the cockpit, sealed and glassed the entire area to make it watertight. The forward deck got a round of filler and putty to smooth everything out, and got a clean, seamless finish. I also wrapped up more of the planking work using Depron. The bow thruster opening though, that needed fixing. I had cut too much out earlier, so rebuilt the area with additional material. Hot glue worked great here as a temporary hold before everything gets glassed over later. Excess material was trimmed back with a knife, and I filled the gaps, especially around the bow thruster opening, so it's ready for an epoxy pass. To clean things up further, I used a larger grinder to remove excess from the bow thruster tube. Then I installed the brushless motor for the thruster. It's only held in place with a single nut for now, but since I can still access it later through the cabin hatch, once I've got more fiberglass on hand, I'll reinforce that mount properly. After that, it was more filling, closing gaps, smoothing surfaces, followed by sanding everything down again. Finally, I moved to the bow section and started fiberglassing. I used 160 grams per square meter cloth, laying up multiple layers along the keel. I went with 4 layers in total to really build up strength where it counts.
Because I've just finished the hull, the fiberglassing of the hull, the stern of the hull, the bow of the hull. I've did multiple layers on here, on the keel, to just kind of protect it furthermore. I'm really excited with how it all turned out. Can't wait to see it all dried up. Again, where the critical parts where I might run into stuff, I put on multiple layers just to protect it, give it some extra protection. But and now, when this is all dried up, it's should be ready to float. So do a float test. I will do that within next weeks or so. But yeah, very excited. A lot of bodywork ahead. And I've just run out of fiberglass, so my fiberglass roll is completely empty. So I got to order a new one for the pilot house. To see more of that, subscribe to my channel, and see you in the next one.